All right, we're finally at the where we need to be. Now, I want to make these announcements. The first one immaterial, whether it gets on here or not, but since it does have to do. Today's class, if you are taking the transportation over to the other campus, it leaves at 8:30 from out front here. If you're driving yourself and you have needs that you need to be there, then go right ahead. I know two of you said that. I don't have to leave before 9 o'clock, so I'll probably stay till 9 and just keep recording. So hopefully some more will be coming in. But I will probably stop sometime between 9 and 9:15, so I can get over there by 9:45. That'll give me plenty of time to put my gown on. Okay. Then also tomorrow, normally I have office hours on Birmingham campus from 7:45 to 1. Not tomorrow. I've got an infusion tomorrow. It starts at 8, so I have to be there by 7:45, and it'll go until about 4:30. So no way I'll be on campus tomorrow at all. Okay. Next, any questions on anything we've done so far? Okay. Got one? Okay, well, try if you want to. Okay. If not, example 2 is find all the vertical and horizontal asymptotes of the graph, and sort of implied here is graph these two rational functions. So let's start with this one. Now, I mentioned to you, they say vertical and horizontal asymptotes, by all means. But I also suggested to you that we also find two other things. What are they? This is on page 170, chapter 2, section 2.6, near the top of the page on 170. Okay? Now, so I suggest you look for 4 things. This tells you vertical, horizontal asymptotes, those are 2. What are the other 2 things that are pretty easy to look for? X and Y intercepts, exactly. So I'll let you choose what you want to look for first. Doesn't matter to me too much. Vertical asymptote? Okay, what determines your vertical asymptote? Say that again, a little louder. I couldn't hear. No, that's horizontal asymptotes. So that's what... Okay, the denominator. You see any places where the denominator would be 0. So let's do that. We know that denominator, x squared minus 1, cannot equal 0, because you can't divide by 0. Now, what values of x would make that equal to 0 that you have to disallow? What would you do? How would you solve that inequality? Help me help. Factor, exactly. And how does that factor? X plus 1 times x minus 1. And that product cannot equal to 0. Well, what does that tell you? A little louder. X can't be... I can't hear. Yeah, okay. X cannot equal positive 1, and x cannot equal negative 1. Okay? Can't equal either one of them. Therefore, your vertical asymptotes are those lines where x equal negative 1, x equal positive 1. So since we found it, let's go on and do our graph. Okay? Okay, don't have a lot of room. So here we'll do 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 1, 2, 3, 4, 5, 6. Negative 1, 2, 3, 4. Positive 1, 2, 3, 4, 5, 6. Okay. So, x cannot equal 1. Now, I like to do, just because the book does, my vertical asymptotes in red. So here, x cannot equal 1, and x cannot equal negative 1. Done. Okay? Done the vertical asymptotes. Okay? These are your vertical asymptote. Well, my pen is not cooperating. Yuck! Okay. Yeah, okay. So this is vertical asymptote. Done. What you want to do next? Horizontal asymptote, okay? How do we do the horizontal asymptote? To say? Ratio of the leading terms. Maybe I should do that in a different color, okay? And what's that ratio of those leading terms? Second? 2. And since this is f of x, this is your y. So horizontal asymptote is y is equal to 2. Everybody see that? Now, since they did vertical asymptotes in red, I'll go and do horizontal asymptotes in red as well, though it's not necessary. So y equal 2, that would be this line right here. And now remember, horizontal asymptote, a function can cross it, touch it, whatever. It's just a vertical asymptote, it cannot. Okay. Now what? What you want to do next? X-intercept. And what's true about an x-intercept? Y is equal to 0. What's your y here? What's your y? F of x. So how do you make this equal 0? How do you want to make this equal 0? Only way it can be 0 if the numerator is 0. You know the denominator can't be 0. I already did that with vertical asymptote. So it's the numerator. If that's 0, then the function is 0, right? 0 over 17 is 0. 0 over negative 4/3 pi is 0, okay? So if that numerator is 0, your function is 0. What makes that numerator 0? Say again? X equals 0. So there's our x-intercept. 0, 0. Okay? Right there. Now, the sad news is that's also your y-intercept, isn't it? How do you do y-intercept, by the way? Normally. You say x equals 0. And if you say x equals 0, you get y is equal to 0. Yeah, so it's the same number. And we don't get any help at all on where things are. Okay? So what we have to do, we've split the domain into the part left of -1, in between plus and -1, and right of -1. We have a point here, but that doesn't tell us which way it's going. So we are going to need a point over here. Actually, we'll probably need 2 points in here. Okay? And we'll need a point over here. The reason we'll need 2 here, just giving 1 point, okay, say we use a 1/2. If it's up here, we don't know if it's doing this or doing that. Okay? If it's over here, then we don't know if it's doing this or doing that. Okay? So we're going to need 2 points here, unfortunately. Okay? So where do you want to begin? Where do you want to begin? Okay? Please tell me somewhere to begin. Pick an x. Give me an x. Second? You can't use 1. It's a vertical asymptote. 2. Okay? She's starting over here. So I'm just going to indicate this is where we're beginning. X equal 2. So if we do, I'm going to clear out some of this too. What we're doing here is f of 2. That's going to give me my y value when x is equal to 2. And what would that be? 8, because 2 squared is 4. 4 times 2 is, okay. And 8 over 2nd? I can't hear you. 8/3, absolutely. When you put a 2 in here, that would be 2 squared is 4, 4 minus 1 is 3. 8/3. Now, where is 8/3? Approximately. 8/3. Divide 3 into 8 and you get 2 2/3. Exactly. So here's 1, 2 2/3 will be somewhere right about there. Guess what? I know where this function's going up there. Don't you? As it approaches the vertical asymptote, it goes toward it but can't ever touch it. And then in the long run, it's going toward the horizontal asymptote. Got that side done. Give me another x. -2 sounds like a great idea. So now we're investigating this. So this time we're doing -2. Okay? And you tell me what happens when we plug in a -2. Say again? -8, because if you put a -2 there, -2 squared is +4 times 2 is +8, and a -2 here is +4 minus 1. It's the same thing. 8/3 again. So we're over here on this one. Okay? So we know where this is going here. It has to approach the vertical asymptote that way and the horizontal asymptote that way. So we got those two knocked. Now the problem is, and y'all put it off till the end, didn't you? You need a couple of reference of values down here. And unfortunately, you need one to the left of 0 and one to the right of 0, but it can't be, between -1 and 0 and between 0 and 1. You choose. 1/2, why not? That's right in the middle, isn't it? So this time, we'll do alpha of 1/2. I think what I'm going to do is come up here, because that's pretty crowded there. Leaving already? All right, good deal. Will you be at the Honors and Awards? Okay, may see you there then. Okay. They've got signing day at 8:30, I think he said. Okay. Or, yeah, whatever. So what we're doing is f of, you said 1/2? And what will that be? What's 1/2 squared? 1/4 times 2 is 1/2. And in the denominator, 1/2 squared is 1/4 minus 1 would be -3/4, right? Okay, now I'm going to slightly redo that as 1/2 times a -4/3. When you change a division to multiplication, you invert and multiply, right? So this is going to be, 2 will go into 4 twice, -2/3. Okay? So that's going to be at +1/2, we're -2/3. Right about there. Agreed? Now, we saw it up here. We should have seen it ahead of time. Now I'm going to bring it to your attention. What kind of function is this as an even or odd? Even. So that means everything is reflected across the y-axis. So we really don't need to do -1/2. If we did it, we're going to get the same thing, right? So that's going to be here. So now we know exactly where this function's going. It approaches the vertical asymptote that way, and it's nice and smooth there, and approaches it that way. Now here's another thing, and this is just a little silly thing, but remember, since the 0 here is determined by the numerator, this is a sort of like a repeated 0, x equals 0, x equals 0, and those touch but don't cross. And sure enough, it's another reason we should have known what's going on there. Once we knew where 1 was, the other one had to be there too. So there's our function. There's the graph of the function. Isn't that pretty? Red, white, and blue. Okay? All right. Any questions on that? Okay, can I go and erase it so we can do the B part? Okay? All right, let's do the B part. What do you want to do first here? You choose. Second? Horizontal asymptote. Okay, so we'll start with HA. And how do we determine HA? Horizontal asymptote? Second? I can't hear you. Okay, no, you're doing vertical asymptote. Okay, she said horizontal. I can do either one, but you tell me. Ratio of the leading terms. And what is that? 1. And what's that? F of x is y is equal to 1. Okay, let's go on and get our graph started here. Okay. Right. Well, now vertical, that's places where the x cannot equal something. That means you eliminate it, and the only thing that determines you can't equal is your denominator. The horizontal asymptote is in behavior. What's it doing in the long run? And that's leading terms. So keep those in mind. All right, so let's tick these off. 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, 2, 3, 4, 5, 6, 7. Positive 1, 2, 3, 4, 5, 6. Negative 1, 2, 3, 5. Okay, something like that. So y equal 1, that's right here. Let's go on and make that red. Though that doesn't have to be, but y is equal to 1 is that line right there. Okay, since they did vertical asymptotes in red, I won't go on and do that. Okay, now do you want to do vertical asymptote in a different color? That way maybe it'll make it a little clearer. Which color? Green, dark green? Okay, I like that. Vertical, verte is green, is French for green, so okay, I like that. V, green. Okay, vertical. Okay. Now, how do we do the vertical asymptote? Woo, goodness gracious. Second, denominator can't be equal to 0. That denominator is x squared minus x minus 6 cannot equal 0. So what do? We do? Factor it. Very good. Okay. Okay, x and an x. And what? Minus 3. You're already on it. Plus 2. So what does that tell you? And x cannot equal negative 2. Very good. Positive 3 is over here. Oh, I think I recognize you from somewhere. Where is that? Okay, Ashland's here. Okay. All right. We're on page 170, example 2B. This is chapter 2, section 2.6. Okay? And we just determined our vertical asymptotes. Okay? Well, x cannot equal 3. There that is. Now, I do red for that. You don't have to, but I do because you can't touch or cross a vertical asymptote. You can touch or cross a horizontal asymptote. I did that red too. And the other one is x cannot equal negative 2. You got that by setting your denominator. You know your denominator can't be 0, so you find out the values of x that would make it 0, and then you disallow that. Can't do it. Two other things that are pretty handy to know when you're trying to graph functions. What are they? X and y intercepts. What you want to do first? It's up to you. X, okay? So let's do the x-intercept. Do you want that in a different color? We're running sort of out of colors, but... Huh? Just keep it in green? Or dark? Dark, okay, let's go to dark, okay? So this will be an x-intercept. Now what's true about an x-intercept? True about every x-intercept. Y is equal to 0. And what's your y in this problem? In every problem almost? It's the f of x. And what is going to make this f of x equal 0? The numerator. Denominator has nothing to do whether it's a 0 or not. The numerator is going to make it a 0, because 0 over 17 is still 0. 0 over negative 2/3 is still 0. In anything, if that numerator is 0, the function is 0. So that's what we do. We set the numerator equal to 0. And what would that give us? X squared plus x minus 2. This is equal to 0, not equal to, equal to. But we do the same thing. What's that? Factor. And that gives us x plus 2 times x minus 1. Y'all are good at factoring, aren't you? Okay. And what does that give us? Either x equal what? Negative 2 or x equal 1. Now those can be and will be. X equal negative. Wait a minute. Did we do this right? Let me check our factoring just a moment here. I believe you're right, but let's see. X squared minus, yeah, that's right, and x squared, yes. Guess what? We should have done this at the very beginning. We should have factored that numerator and denominator, because guess what? We have a common factor. So this x equal negative 2, it can't be negative 2, but that is not a vertical asymptote. Sorry about that. I wasn't paying attention. Okay? Most of the time they don't do that to you, but they did this time. Let me make sure I copied the problem right. Yep. Okay, I did. So that eliminates that vertical asymptote. Still, x can't be negative 2. You still have to keep on hold of that, but that's not going to give you a vertical asymptote. So now we're down to this. Now our other one is x is equal to 1. We can do that one. Okay? So let's do x equal 1. That is a, and by the way, it's a 1, 0. Because this is an x-intercept, that's an ordered pair, 1, 0. Because we set y equals 0, found x equal 1. We know x can't equal negative 2 from down here. Okay? Now, frankly, that's all we need. Because we know the function has to stay in this quadrant, so it's going to approach the horizontal asymptote this way and approach the vertical asymptote that way. Okay? So let's do it. It's going to approach here. But remember, x can't be negative 2. So at negative 2, you have a hole in the function. Okay? That's literally what you got. It comes up to there, and whoa, it's not supposed to cross that. And then it goes down here. Okay, see you over there. There is how it looks on this side. Whenever you have a common factor, that produces a hole in the function. Wherever that happens to be going, it has a hole there, because it can't equal negative 2 from there. All right, and we got our x-intercepts. The one last thing we might need to do is y-intercept. And how do you get y-intercept? Always. If your x-intercept is where y is equal to 0, guess what the y-intercept is? Where x is equal to 0. Well, that's pretty easy to do. Let's put 0 there and 0 there. What do we wind up with? Second, positive 1/3. And so that one should have been right there. So I didn't have my graph quite in the right place, but we'll just pretend I did. Okay? So that didn't help us at all. That's both in the same quadrant. So now what do we need to do to finish the graph? Say again? Yeah, we're going to have to pick another x, and you tell me which x you would like to do. You got everything over here less than 3. So pick something greater than 3. Pick one. All right, she likes to go for the big ones, okay? All right, let's see what happens here. Let's put in a 5. And in this case, we'll put f of 5 right here. And what would that be? Now, ignore my crosses before. That was for the purposes that we were doing at the time. So now let's do x equal 5. What do you get? 5 squared is 25 plus 5 is 30 minus 2 is 28 in the numerator. And the denominator is 25 minus 5 is 20 minus 6 is minus 6, not 16. Duh. Okay, minus 6 is what? 14. And what's 28 over, wrote 12. 28 over 14? 2. So this is 2 up here. Right there. Ha! I know where this one's heading. As you go toward infinity, you're approaching your horizontal asymptote. As you go toward the vertical asymptote, you can't ever touch it. There it is. There's your function. Only little strange thing here, you have a hole in it right there because x cannot equal -2, but it's not a vertical asymptote. It's a hole. Okay. They didn't show you this one. Shame on them. But there we found the vertical and horizontal asymptotes. That's all we really were looking for. So let me erase unless you have any questions, let me erase this. And we will see what they did. Okay, on the first one, the A one, for that rational function, the degree of the numerator is equal to the degree of the denominator. Did we worry about that? Not really. What they're doing that for is to see if you have a horizontal asymptote. Just cut to the chase and look at the ratio of leading terms. So much faster than trying to worry with degree. Look at the ratio. X squares cancel out, and you have 2 left. Done. That's your vertical asymptote. Now, if this had been an x cubed up here, and that x squared down here, that would have been a 2x. As x gets large, the function gets large, so it's going to positive infinity. As x gets very small, it's going negative. So hang it up, Jack. That's not doesn't have a vertical asymptote. I mean a horizontal asymptote. If the x cubed was down here and the x squared up there, then it would have been 2 over x, the ratio, right? If that's x squared and this is x cubed, you have 2 over x. As x goes very large numbers, that's going to 0. Okay, so that would be your horizontal asymptote. So don't worry. I mean, yeah, you can do it by the degrees, but the thing is, just look at the ratio of the leading terms. That does it for you, and it's so much easier and faster. Okay, the leading coefficient is 2, the leading coefficient is 1, so that the graph y is equal to 2. Yeah, if you just did ratio of leading terms, you'd already had it. Y is equal to 2. And that's what we got. To find the vertical asymptotes, set the denominator equal to 0, and that's what we did. We did that first. They set it equal to 0. I like to say it can't equal 0 because you can't touch it, you know. Denominators cannot be 0. But it doesn't matter which way you do it. Factor that, x plus 1 times x minus 1. That gives you x plus 1 cannot be 0, and x minus 1, and that gives you x equal -1, and x minus 1 can't be 0. That gives you x equal, or not equal to, plus 1. Okay? That gives you your 2 vertical asymptotes there. Okay? So the equation has, so the lines x not equal to -1 is a vertical asymptote, x not equal to plus 1 is the other. You can do it either way, but just know those are vertical asymptotes. Okay? So we did y equal 2, we did x equal -1 or positive 1, and they just threw the x in there. If you had done your intercept, you'd have found one intercept here. The only way you can get this is test the value. You didn't have to use -2, you could use anything you wanted to. But something left of -1. And then you need at least one point in here, And if you recognize that's an even function, once you have one side, you got the other side. So once you have this, you know it's over there too, or whatever. Okay. But if you don't trust that even and oddness, check another thing. You'll see it's true both ways. All they asked for were vertical and horizontal asymptotes. We got those. We went ahead and graphed the function as well. Okay, on the B one, for that rational function, the degree of numerator, again, they're messing around with degree. All you have to do is take the ratio of leading term, and that's 1, so y is equal to 1 is your horizontal asymptote. Find the vertical asymptote, first factor the numerator and the denominator. I didn't do that. I knew we were going to factor it later. That's why I asked you to go on and give me the things. But when you factor both of them, you see you have a common factor. So you can only talk about the vertical asymptotes if there's no common factors. So this makes this a vertical asymptote. This makes that a whole other function. So x equals 3, vertical asymptote, x not equal -2, that's your whole other function. Wiped out there. Okay? It also gives you your x-intercept, x equal 1. Okay? Okay. They also say x cannot equal -2, but your function you're graphing is that one right there. X minus 1 times x over x minus 3. X equal 3 is vertical asymptote. X equal 1 is your horizontal, is x-intercept. Y-intercept is 1/3. You can tell that looking at that too, and that's what we got before. Okay, they didn't graph it. Okay, but they got the horizontal asymptote. Y is equal to 1. Vertical asymptote. X can't be 3. Okay. Shame on them for not graphing it. Now, there is a checkpoint there. Good idea to do your checkpoints. Okay? Let's move on to sketching the graph of a rational function. We've already been doing it. There's nothing new here. Let's just see what they say the guidelines are. Okay? You don't have to do a particular order. Oh, I don't know what that is. Okay. But here's what they suggest. Let f of x be your rational function ratio of two polynomials, where n of x is a polynomial in the numerator, d of x is a polynomial in the denominator. D of x can't be the zero polynomial. If it is, you don't have a rational function. You have undefined. But if it's any other rational function other than zero polynomial, if it's any other polynomial other than zero polynomial, you can. Now, here's what we didn't do before: simplify if possible. In other words, if that both can be factored, factor them, see if you can eliminate any common factors. That's what we didn't do on the B part. Find and plot the y-intercept, if any, by evaluating f of 0. That really is the easiest thing to do. You don't have to do it number 2, but it's an easy thing to do. Do it somewhere. Just don't forget about it. Okay? Find the zeros of the numerator. That's going to be the zeros of the polynomial. So that will give you your x-intercepts. Now, usually they did that later. You can do it now if you want to. Then find the zeros of the denominator, if any, because that's going to give you your vertical asymptotes. Okay? And find and sketch the horizontal asymptote by using the rule for finding the horizontal asymptote for the rational function. Oh boy, that's a real clear statement, isn't it? Do the ratio of leading terms. Okay? That's what you do. Okay? Rather than their 3-point rule, you know, ratio of leading terms. Then plot at least 1 point between and 1 point beyond each x-intercept and each vertical asymptote. And that's what we did before. Once you got your vertical asymptotes in place and your x-intercepts in place, then it said plot a point between and beyond each of these. You don't have to do them all. If you get something up here and you got a whole quadrant here, you get 1 point, you know what's happening. Okay? If you got between two and you got a x-intercept, yeah, you're going to have to generally do one on either side. And that's why I said do that. until we recognized it was an even function, then we said, you don't have to do that. But if it's a neither function, you got to do it. Even or odd function, you could probably figure it out. And then out there, usually just 1 point will do. You use smooth curves, no points or cusp or anything else. Smooth curves, because these are polynomials, remember, to complete the graph between, beyond the vertical asymptotes. That's pretty much what we were doing. And you can do whichever order of those. You've got 4 things you're looking for, do them in any order you want. Okay? The concept of test intervals can be extended to graphing rational functions. And that's exactly what we're doing. To do this, use the fact that a rational function can change signs only at its zeros or its undefined values, which are the vertical asymptotes. Okay? So that's why we use the zeros and vertical asymptotes and pick points in between. Between 2 consecutive zeros in the numerator and the denominator, a rational function must be entirely positive or entirely negative. That's basically what we were doing. Okay, this means that when put in order, the zeros of the numerator and the denominator of a rational function, you can think of as zeros of the denominator. Think of it as vertical asymptotes. That's what you did. That is the zero denominator. Divide the real number line into test intervals for which the function has no sign change. So if you find out what it is there, you got it done. Okay? Choose a representative x value to determine whether the value of the rational function is positive or negative. Now, you're really looking mostly for the sign, but the value tells you how far up and down to go also. The graph lies above the x-axis is positive, negative, the graph lies below the x-axis. Basically what we did. So here, let's do example 3. Okay? Let's sketch the graph of this function and state its domain. What you want to look for first? You choose. X-intercept? Okay, let's do it. X-intercept. What's true about every x-intercept? Y is equal to 0. How do we determine what y is? Y in this case is not an f of x, but a g of x. When is that 0? When the numerator is 0, isn't it? And is 3 ever 0? No x-intercepts. None. Okay? Which leads me to suspect that that's going to be your horizontal asymptote, the x-axis. Pretty good guess. If there's no x-intercept, that's probably going to be the horizontal asymptote. But we'll see. What you want to try next? You struck out on that one, didn't you? Okay. No, you found out something. There is none. Next. Y-intercept. Let's do that one. That to me is probably the easiest most of the time. And what was that? What's always true about a y-intercept? X equals 0. If x equals 0 there, what do you have? That's y is equal to negative 3 over 2. Is that what you said? Negative 3 halves. All right, I can start my graph now. I could have started earlier, but I wanted to have something to put down here. So let's do a 1, 2, 3, 4, 5, 6, 7. Ooh, that's not very even. Negative 1, 2, 3, 4. Okay, positive 1, 2, 3, 4, 5. Negative 1, 2, 3, 4. Okay, got it. So y, okay, I sort of said that wrong. A y-intercept is where x is equal to 0 and y is equal to negative 3. So that makes an ordered pair 0, negative 3 halves. So where is that? Second, down 1.5. Exactly. Negative 1.5. That's a y-intercept. Okay? What you want to do next? Vertical asymptote. This case is going to be pretty easy. What's that? Say again? Say again? Set the denominator equal to 0. X minus 2, I like to say, is cannot equal 0. Reminding myself it can't go there. What does that give you? X cannot equal 2, right? So here's 2. X can't equal. Ooh, I like to do that in red, don't I? Okay. Okay. X cannot equal 2. Okay, what you want to do next? Okay, horizontal asymptote. I'll do this in red. And how does that come into play? Ratio of the leading terms. 3 over x. As x is very large, what happens to 3 over x? Goes to 0. Because 3 over 10 is 3/10. 3 over 100 is 3/100. 3 over 1,000 is 3,000. It's getting closer and closer to 0. So sure enough, that's why you had no x-intercepts. Your x-axis is your horizontal asymptote. Okay? Now, I know already, because I'm psychic, where we are here in this lower quadrant, because there's my y-intercept. I know it has to be approaching the x-axis there and approaching the x-intercept, asymptote, horizontal asymptote there and vertical asymptote there. Got to be, okay? But I don't know what's going on the other side. So what do I want to do? Say again? Yeah, choose an X. You choose one. Three. Why not? So we'll choose this X right there. Okay? So what we're going to do is look at the whole function. What am I doing here? Okay. G of 3. What would that give you? 3 over is, second? Okay, 3 minus 2 is 1, so that would give you 3. So x equals 3, your y is equal to 3. Right there you are. Guess what? I know where it's going now. It's going up this way and going down that way. There's your graph. Oh, state its domain. What is the domain of that function? Oh, it's been a while, hasn't it? That was chapter 2. We forgot that, right? We've already been tested on that. No reason to remember it. Wrong. Okay. So what do we do? You can look at the graph and tell you. What's the domain of that function? X equal 2. Exactly. Everything over here, everything over there, you just can't be x equal 2. Undefined there. So you can write it out that way. All real numbers are got to x equal 2. You can say the set of all values x such that x is not equal to 2. That's another way you could say it. Or you could give it in interval notation. You tell me what to write in interval notation. Where are we going to this way? Negative infinity, okay? It starts at negative infinity and goes everywhere up to 2, but then does not equal 2, so we put a parenthesis there, and we union that, and where do we pick up again? 2, but not 2, okay? And then go all the way to positive infinity. You remember that, don't you? Okay. That shows exactly what's going on there. That, to me, is the simplest way, but you can write it out, set of all real numbers, except x cannot equal 2. Okay. All right. So, we've stated the domain 3 different ways. I didn't write the first way. So let's clear this off the screen, and we'll see what they did. Oh, they started with the y-intercept. Somebody was looking at the book, weren't they? Okay, so that was 0, -3 halves, sorry. No, they didn't. We started with the x-intercept. So they started with y-intercept, set x equals 0. You get 3 over -2, which is -3 halves. So g of 0 is that. So I like to actually write it as an ordered pair, 0, -3 halves. But that's fine too, okay? Oh, they already did it. They wrote it here. Forget that, okay? Okay. Next, they did the x-intercept. None, because 3, the numerator, can never equal 0. So there is no x-intercept, okay? Which leads you to think maybe that's going to be your horizontal asymptote, but we don't know that for sure until we test it. Vertical asymptote is where that the denominator can't be 0, and that means x can't be 2, okay? So that's the 0 in the denominator, and the horizontal asymptote is where the ratio of the leading term, now they talk about degrees, if you look at this ratio and let x get very large, that's going to 0. So y is equal to 0. So sure enough, the x-axis is our horizontal asymptote. So how do we, okay, so let's sketch the graph. Oh, now they do additional points. Yay for them. We really didn't need all those, but they did them all. But let's see how that improved the graph. They picked x equal -4 because it's left of 2. Negative, I mean, 1 would have been fine. Then something between, oh, let's see. Oh, yeah, oh, they just did 2 more. Left it of 2 and right of 2. Okay, that's fine. Because there were no horizontal asymptote. I mean, no x-intercepts. So they just did that. This was the only one we really needed, and we did that one too. Okay. Now, did that really help us any to know the value of that point? No. Once you do this, it's going to place horizontal asymptote there, vertical asymptote there. It didn't really help. It maybe helped me place it a little bit, but no big deal. Okay. All right. I wouldn't waste my time. But the next one you did need, and sure enough, that told you where to place it. So we got it. We found the asymptotes. We found the intercepts. We graphed the function. Got it knocked. Oh, and then the domain is a set of all real numbers except x equal 2. We said that too. I didn't write it out that way, but that's how they did. Okay. They're skipping example 6. Okay. So let's go back, and that's not the best place. Let's do it. Ooh, why example 6? No, they're not just skipping example 6, they're skipping example 4, 5, and 6. Okay, so let's do 4. I think we got time. Let's see if we can do 4. Okay. Sketch the graph of f of x is equal to 2x minus 1 over x. Okay. And state its domain. Same thing here. Okay. So sketch the graph, just a different function here. Now, where do you want to begin? Second? Second? Okay, we can start with the x-intercept, and what will tell us that? What's true about x-intercept? Y is equal to 0, and what's your y? F of x, and what will make that f of x 0? The numerator. So that's going to be 2x minus 1 equals 0. Right? Solve that. Second? 1/2. Got it. X equal 1/2. really quick. Okay, so there's your x-intercept. Will be 1/2 0, because your y is equal to 0. Okay? What you want to do next? Y-intercept. To me, the easier one. And what's that? Ah, and what happens if you try that? Undefined. You can't have x equals 0. So there is no y-intercept, okay, because x can't be 0, okay, which indicates probably the y-axis is going to be a vertical asymptote, okay? So what you want to try next? You got your two intercepts. Now we look for your asymptotes, and what you want to draw first. Second, vertical. Vertical asymptote. What's going to be true about that? The denominator can't be 0. So therefore, x cannot equal 0. So there's your vertical asymptote. Okay, that was pretty easy. We suspected it when we saw no y-intercept. Okay. And then that leaves us one. And what's that? Horizontal asymptote. And that's going to be what? It's the ratio of the leading terms. And what's that? 2/1. So y is equal to 2. Okay? That's all the information we can glean from the problem easily. So let's plot what we've got so far. 1, 2, 3, 4, 5, 6, 7. Negative 1, 2, 3, 4, 5, 6, 7. Positive 1, 2, 3, 4, 6, 7. And negative 1, 2, 3, 4. Okay. So, x-intercept is 1/2 0. 1/2 to the right, 0 up or down. There's the x-intercept. Y-intercept none. Vertical asymptote is your x equals 0. So I'm going to do that in red. Red. So the book doesn't usually do this. I like to do it. Superimpose. I guess the typeset is hard to do. Okay. So no y-intercept. Vertical asymptote, we did it all at once. Horizontal asymptote, y is equal to 2. There's y is equal to 2, and then make a horizontal asymptote there. Okay, we got a point right here. Right? You know, here it's going to the vertical asymptote, here it's going to the horizontal asymptote. You got that one done. You don't need a test point over there. But you might on the other side. So what test point might you choose to use? Yeah, pick one. Yeah, -1. That's a real simple one. So let's plug in that. F of -1 would be, let me erase this stuff out of the way so you don't get confused by it. Okay. What would that be? -3 over -1, which would be 3. So this, you're at 3, 1, 2, 3. There you are. I know where it's going now. Vertical asymptote that way, horizontal asymptote that way. There you have it. Done. Make sense? Okay. Now, I don't think we're going to have time to do example 5. Do you? We might be able to squeeze it in, but y'all are easy. Okay. We'll start next time with that. Let me give you some homework exercises. I know you want that. Do either 5 or 7, any of the odds 9 through 15, any of the odds 17 through 39, I would do all of 41 to 44, but only the odds 41 and 43 answers will be in the back. Think you can do either 45 or 47 and stop there. And if you get bogged down before that, we'll come back and do some more in those other examples. So we'll go from there. Sorry about having to cut class short today, but with Honors and Awards Day, have no choice, okay? So I hope y'all can go to the ceremony, but if you can't, classes should resume sometime around 12-ish or so. So if you have a class with an adjunct instructor, check with that instructor to make sure he or she isn't giving class now. They don't have to be at Honors and Awards. I do, full-time faculty.